AI and ethics, addressing biases in machine learning algorithms. So, for this, ladies and gentlemen, please join me to welcome on stage the moderator of this session, Mr. Rajnil Mallik, partner PwC India. Now, I'd like to invite the respected speakers for this session. May I please invite Mr. Arul Kumar, Expert Enterprise Application, Architecture and Governance, National Payments Corporation of India. Mr. Karthik Kanagaraj, Chief Manager, ICICI Prudential Life Insurance Company Limited. Mr. Chandan Pani, Chief Information Security Officer at LTIMindtree. So at the end of the session, we'll be taking few questions, if time permits. So now I'd request the moderator to please take over from here.
Okay. Well, thank you for waiting patiently on this lovely day. Uh, the topic is extremely fascinating. How do you address and respond to bias in AI and machine learning models? And you know, the more human-like machine learning models become, we get to understand how the human mind works, but that goes hand in hand in essentially our responsibility of how do we deal with such biases and ensure proper administering of such models. So, ladies and gentlemen, esteemed attendees, business leaders, I'm extremely delighted to welcome you today to GFF. And, you know, uh, the topic is, as I said, very, very pertinent. Because if you think about it from a very simplistic perspective, any one of these words, bias, trust, transparency, they're very simple to understand, but not so easy to define in a systematic and a programmatic way. So that's why we have the expert panel here today to talk about it. And I would like to introduce them and welcome them on stage. First of all, thank you for your time, panelists. I have with me Mr. Arul Kumar, who is from the NPCI. He leads the architecture, governance, and code quality for NPCI platforms, both centralized as well as decentralized. He's been in the industry for nearly 25 years, and he has looked at UPI, blockchain, so he knows this inside out. Uh, to his left, I have Karthik Kanagaraj. He is Executive Vice President and of the BIU and the CEO's office at ICICI Prudential. He's been with the company for nearly 20 years, and he's obviously extremely highly experienced in life insurance and FMCG. And he's handled roles in sales, obviously data science, digitization, finance, and so on. So welcome, Karthik. And to his left, we have Chandan Pani. He is the Chief Information Security Officer at LTIMindtree. He leads LTI's global InfoSec and cyber risk strategy. Again, lots of experience in IT and InfoSec leadership experience in banking, telecom, ITES, healthcare, and obviously in multiple markets, the US, Europe, and India. So welcome, gentlemen. Before we get to the topic of the day, I thought I should just start by talking about and asking each of you, what's the most exciting thing in AI that you are working on? If you could just maybe go around. I will start with you, go to Karthik, and then come to Chandan. What's the most exciting thing in AI you're working on?
So one of the important aspects that we are working on right now, we were building components for platforms for NPCI. One of the important components is the data. Data is very critical for us. So we are building a kind of a storage layer, which a lot of open source product underlying a lot of storage engine, so that we will minimize the data loss while we traverse across across the sites. The important aspect is there are a lot of hardware, a lot of transport layer used across these data centers. We always have uncertainty. So if we have a model which can learn and understand this transfer rates and the risk involved to adapt to the current context, it's very interesting. we can run, seamlessly from any side to any side. Even though it's not front part of the business, but ultimately data is very critical. So we are building that, and it's more of a self-learning models that incorporated within the software components, which actually learns and improves based on the current context of it. That's what we are doing right now.
Thank you.
Uh, Thanks, Rajnil. Our focus, the most exciting thing what we are trying to do is to how to improve the customer experience. Insurance as a thing, particularly life insurance, if you want to buy a policy, it's a long drawn process, right? You have to fill in long amount of forms, and then even the issuance or acceptance of the risk happens after a long time. Compare this with a mutual fund. Okay, it is okay for a pure term policy. A term policy is one where you pay a premium and you get some sum assured, and payout happens only death happens. But there are products which actually a savings component attached with the life insurance. Okay, usually that's what is mostly sold. So that product is very similar to, let's say, a mutual fund or any other savings product. If you want to open an FD, if you want to invest money in a mutual fund, it's very easy to do, right? It can happen in mutual fund, it can happen within 1 minute, right? But if you try doing that in insurance, it takes long time. So one of the things what we are trying to do is that how do you develop an AI solution, AI ML solution, which actually addresses this point. Okay, as a customer, you come in, you verify yourself, this is your KYC. Okay, then you somehow we predict your income through various markers. Then you predict the risk, health risk also, and then finally you do a various other predictive models, and based on that you can kind of issue the policy. Imagine if if an agent is sitting in front of you and you are buying a savings product, savings life insurance product, and then within a minute you actually get the policy in your hand, right? Just like buying let's say a car insurance or any other general insurance thing. That is what we are kind of reimagining thing. To give you an idea, today we are talking about 1-2 minutes within which we are issuing a policy. Usually it takes anywhere between 24 to 72 hours in a normal sense. So you can see that from there you are kind of crunching it to a kind of a 1 minute kind of a time or over the counter kind of a thing. So this obviously have to mimic the human performance, but usually what happens is you apply, then somebody picks up your document and verifies it and passes your KYC. Okay, then somebody called an underwriter who's actually looking into each one of your details from the application, and then accessing the risk, mortality risk, and a fraud risk and everything, and then passing it and then doing it. So you have to mimic the whole human intelligence which is there in multiple layers, and then kind of do all of that within a minute and then kind of issue it. That's the most exciting thing what we are trying to do, Rajnil. If you're able to do that, that will be the an industry changing thing which will be there.
Yeah, it sounds like it's as simple as buying something on your favorite e-commerce
Exactly.
site, right?
Exactly.
So
that's the idea we want to kind of replicate. That's an idea what we are kind of working on.
that'll be industry changing, I'm sure.
Yeah.
Chandan.
So as a service company, our landscape is slightly different. So what we do, now when it comes to AI, couple of years ago, we used to do descriptive AI work. When I say descriptive AI, we used to take something, analyze, and tell what went wrong. And we used to help our customers by doing different kind of analysis. Now, moved on, then we started doing something called predictive analysis, right? Now, we try to predict the future by using some of the ML technologies. Now, with the current, probably last couple of quarters or year so, we are now started working on something called prescriptive AI. Now, gone those days where you are only talking about future. Now, we can also prescribe based on your past or future requirement what you are supposed to do. See, for example, some of the solutions, let's say, what is the weather outside? Now, that is a pretty standard question, and a lot of models are there. They can tell you what is the weather. But do you need the umbrella? That's the question you would like to know. I mean, I don't care what is the weather outside. So a company like us, we are trying to help organizations to figure out whether you need that prescription or not. That's the future of AI, and that's where we are.
Thank you. Extremely exciting. I'm sure a long way away from just mere dashboards to where we are.
Absolutely.
But coming back to the topic on hand, perhaps we should start by talking about what exactly do we mean by bias and why that is a significant problem. As Arul, you have seen these systems at scale, and payments is something which is extremely, I mean, it has multiple touch points with the customer. You have to make sure all of that goes correctly and prevent abuse at the same time. So in your experience, if you could talk a little bit about what you mean by bias, how do you see it emerge? Maybe that'll be a good way of setting the context.
Thank you. So one of the important point is AI is data. So whatever model that we talked about today all runs with the historical data. The historical data, sometimes captured very well and without any biases or full of any information. Sometimes the data itself has regional biases and has discriminations, has some sort of for example, that when you do recommendations, basically you wanted to buy a camera, you started pushing camera, but you may not like it at all. So the recommendation is basically based on some data collections, based on your wishes that you've done in the past. So again, there is a bias. So the important thing is, the historical data sets and the algorithm what you use to predict this, stuff. Always it's statistical. It's a probability theory. So you cannot 100% rely on those stuff. And if you want to rely on a kind of a, it can be an assistant, super intelligent assistant, or a kind of a smart assistant. That level only today it is there. So you have to be very cautious.
Absolutely, thank you. Karthik, how about yourself?
So let me first say that yes, any AI ML model will have some bias, right? Like how Arul was explaining. But inherently the bias may not be a bad thing because the model itself works and able to predict because it has certain biases inbuilt, because it is able to see the causality between certain variables and the event what you are trying to predict. So it will be there. Okay. Now where the bias becomes bad is if it becomes discriminatory. Okay. If you can't have a model which is actually discriminating for a particular group, and this is where it becomes a little bit of a problem area. So while bias will be there, okay, as long as it is transparent and it is good, it's fine. But if the bias is going to become discriminatory and one section of group, I'm not going to recommend something, or I'm not going to offer a product or something like that, a service or something like that, then that becomes a issue. So that's a standpoint what we'll have to look from, because the models will obviously have some amount of bias which is coming in.
If I could just ask you one follow-up question on that. Have you looked at maybe perhaps root causes as to how some of these biases emerge?
Yeah. So if bias comes through 2 or 3, 4 major reasons. One is that the kind of data what you are using to train. Okay, let me give an example. In a insurance field, mortality is always correlated to your age. So what you can see is that then if you train a model with the age as a factor, okay, what will happen? The model will learn that all the older people will have higher mortality. Okay, which may or may not be true, right? It depends. It's just age is not one factor, but you will have multiple other things what you want to kind of look into it. So that is one thing, which is basically the data what you are actually using to train the model is not actually reflecting the reality. For one more example, I'll give you. Once in a century event, COVID happened, right? So there were a lot of mortality, extra deaths which has happened, and a lot of these extra deaths also happened with the insured companies, right? Now, if you try again building a mortality model now, including COVID data, you will end up, actually predicting more deaths. If I end up predicting more deaths, what will happen? Then my price of the premium will go up, because your premium is nothing but an expression of how much deaths you are expecting, right? So if I'm using a data to model mortality, particularly in the last 3 years, if I want to build a model and use the COVID data into it, then I will definitely see some amount of higher higher things which can come in. So basically you need to see whether the data what you are using is actually the data what is happening. One more example I'll give you. If you want to train a model to understand if some customers have grievances, okay, complaints, they have some complaints against that. Suppose if you are training this model only using, let's say, information from the social media where somebody has ranted in Twitter or any other place, some place somebody has told that. you will, of course, you will get a prediction. But what that thing will ignore is that it will ignore large amount of customers who have some grievances, but they haven't put it in the social media, right? They might have, but your model will perfectly predict, okay, there is somebody, there who's going to come back with this one, but that need not necessarily cover the whole population. So this is how the biases, the root cause is that the data what you are using for training, that is the fundamental issue what we need to kind of address.
I think both of you are saying the same thing, that data becomes very, very crucial.
Yeah.
Chandan, from your vantage point where you sit, you talked about going from descriptive to prescriptive. In that, have you seen your customers look for certain kinds of solutions which deal with biases in a certain way? Do you see, maybe the tech stack changing in a certain way? How do you see this change manifesting in what customers are asking for?
See, definitely we see there is a change. There is a change in terms of what customers are trying to do now. Now, specifically to talk about the bias piece, bias comes from your input data. It comes from the processing side also. Also, it is during output. Now, as a service provider, it is our job to ensure that we take care of all three. See, when I say input, probably data is one best example. We are talking about input side of the bias. Now, if the data is biased, we understand the output is going to be slightly biased. Now, bias is something which is a kind of overloaded term. We kind of use bias for everything, but in a data science world, people use bias for many other reasons as well. Now, it is kind of a standard, just like economics, we use inflation for various reasons, right? Not necessarily it is bad always. Similarly, bias is not always bad. So there are reasons for that. There are your MI-op models are there. There we work with bias, we work with weightage, we work with data labeling. Now, what happens is, let's say I am doing some kind of reinforcement training. If I am training the data, then it is quite possible during the processing, I might as well influence the way the data is actually going to behave. Now, the output side of it, see, sometimes whatever you process and the inference is not going to be the same. It is slightly skewed because of whatever reason. See, sometimes the models, they learn in a different way. Now, say for example, I'm just talking about some of these recommendation engines. Let's say, randomly picking Netflix. Now, if you see some movies are rated very high. Now, it is rated by the folks, they wanted to see that movie. It is not by everybody, right? I wanted to see a movie, I liked the movie, and I have rated it. Now, it has nothing to do with you. Now, if I'm going to pick all the highly rated movies, then I'll end up with partially probably skewed data, which was rated by the folks who wanted to watch those movies. Now, that's how some of these biases are not consistent also. See, if you look at, for example, a very simple mechanism. If you log into shadi.com or something where you have a prediction model, it throws you some data. Now, on basis of what, nobody knows. You have given your name. I mean, you just want to marry somebody, but the model tells you, okay, these are the 5 profiles there in front of you. Now you choose. Now, all of you know what happens if you believe on that. So the models are slightly different. See, for example, there's a very famous use case. There used to be a bot called Tay. Now, Tay is a product of Microsoft, which used to be there in probably 3-4 years ago. When it started with a kind of a bot enabled on Twitter to help people with certain queries. But Microsoft had to shut it down within a couple of days because it went completely racist. So within those few days, people started feeding data. And it started acting on those data points, what was given to the bot by public. Now, those kind of issues are there where you are using some kind of model, you are using some kind of input data and the processing. So when we talk to our customers, we always ensure that we try to establish the context. We try to establish what is that customer is trying to do. We also try to figure out what are the best ways to deal the data. Now, it is quite possible that customer is giving me some data which is not complete. Now, in that case, I'll not be able to do anything with that. So certain amount of bias is going to be there. So these are some basic validation checks we do when we work with our customers.
So
Yes, please go
I
ahead.
just want to add a couple of more points. One is on, one I spoke about the faulty database. The second one is also about incomplete data, which is what he was talking about, in the sense that you have got a data which is only people who are wanting to watch the movie and do it. It happens, for instance, in insurance sector, if I have to give a thing, there is a customer, and then there is a distributor, and there is a insurer, and then there is regulator. There is complete, information data asymmetry which is there. So customer have to, truthfully declare what is his health status, what is his income. Distributor who's seeing the customer have to clearly give this is what it is. Then insurer, have to transparently price a product which is fair to kind of everybody. Okay, so there is you suppose if a lot of customers don't declare their proper income, for instance, not even in a range, they simply put 5 lakhs, right? Irrespective, they're thinking, why should I tell this? Now, this is the data which is coming to the insurer. So when you are trying to model with that number, then it may or may not be the right, it will give you may or may not be the right results. This is another issue which is there. The other problem, what the Microsoft thing example is there, is that a model is an abstract of the human processes. If you are actually, there are some loopholes, or there are some inherent problems in the process which is there, right? The human process which is there, it will reflect in the model also. Let me give an example. If you are recommending a particular product, or if a particular product is being sold to a certain segment of customers, which may not be a suitable product, but it is easier for to sell, so people are selling it. Okay, it can happen in any industry. Okay, now if you want to build a recommendation model, now the data what you have is that for this customer I have sold product A, right? But actually suitable product is C. But lot of times I've ended up selling product A, my product recommendation engine will end up only showing product A as the right product for this customer, but actually the right product is product C. This is one of the typical problems what you will see, that in any of the product recommendation engines, or any of the next best product kind of a this one. This is the second one. There is an abstract of the process which is already existing, and also incompleteness of the data. People don't reveal their actual data. These two other root causes which actually create the bias, which the model kind of amplifies.
Is it then fair to say that the data, and let's assume that every model is biased, maybe to some extent, but learning from your mistakes is perhaps equally important. In fact, the Microsoft story has a happy ending in which the CEO said, "Well, you guys, it's not your fault. You did the best thing, but learn from your mistakes and don't make the same thing again."
Yeah.
So maybe there is that angle too. So Arul, let me come to you. We talked about some of the examples. I'm sure from the vast amounts of data that you are seeing, the vast amounts of customer behaviors that you're seeing, bias tends to play a role in thinking about what are the possible, not just business issues, maybe even social, ethical issues that you worry about. If you could talk a little bit about that.
I think one of the examples that we have today is regional biases. Regional biases, respect to India, respect to overseas also. If you look at some of the statistical against the justice, law and risk, I think it's proved that colored versus white combinations, it's like a 60 to 28. If you put the kind of where the regions, where the locations are, if you remove it, that is very close by. So, one thing is data itself skewed, because while you collect the data, you don't collect the data. Sometimes it happens that if you do not have a full of government, there are countries which you do not have data at all, but doesn't mean that they will not have. So if you calculate something against that particular region or country, you will find a very low score, but it doesn't mean that it's very safe for it. And I think there are scenarios where people were used to use the X-rays to understand the molecules behind the things, and sometimes somebody put some small, scissors or some related operation theaters instrument, and then finally it came up with the molecules. But it really not. Now, we do not have a clear evidence of how do you, real time predict and detect that there's no option for it. But today, I think a lot of improvements been there, and especially if you look at understanding human proteins, I think the DeepMind has 2 million proteins they will understand. So that's great, but I think still it exists. I think regional, and there was one example that the Reuters company recruitment, I think male versus female, I think since there are a lot of not people, there also we had gender-wise biases that we could clearly identify, they rejected all female candidates. So there are many evidences respect to religion, respect to discrimination. There are there, but certainly there is a need for kind of a standardization and understanding metrics towards that.
Need for standardization, absolutely. So now that we have set the context, maybe we talk a little bit about how we are dealing with this today, and then maybe a little bit later we'll talk about where do we think things need to change. So Karthik, if I could go to you and ask you to talk a little bit about, in your experience, what do you see working really well today in dealing with and handling, data-related bias, algorithm-related bias, making sure the workflow works the way it should?
Okay. So there are a couple of fundamental principles we want to work with. One is that any model what you're making, it should not be discriminatory, in the sense that when we are collecting information, you collect information about the customer, demographic information. You also collect information about the lifestyle, health information. But what you don't want to collect is, you don't want to understand about the ethnicity, or you don't want to understand the language, or caste, or religion. Any of those personal things you don't want to collect. And then you definitely don't want to model any one of those things. So it becomes discriminatory to any group in particular. Okay. So that is one thing. So you want to completely avoid any discrimination which is there. That's the first principle. Second principle is that in terms of human oversight, a model can always flag a particular risk, but what it should not do is, it should not execute the decision. The final decision and the flagging are two different things. Okay, let me illustrate with two examples. One example is that we have a model which determines whether we are going to get claims or not, okay, from a particular customer. Now, one way to approach this is that if the model says claims are going to come, I completely shut down that customer and reject that application. Right? That's one approach I can take, saying that I will not get claims. Okay, but that is discriminatory, right? It's not on this one. So so what we do is that then you send that application to a human, an underwriter, who actually pores over the data, understands it, and then decides whether I will accept this application or not. So a fair hearing is given to the customer, so that he basically understands this and gets this done. So that's a second principle which is there, which is a human oversight. Okay, non-discriminatory, human oversight. These are the two guiding principles which are there when you are kind of building the model. Okay. The other thing is that you also want to look out for, because some of these are learning models, you want to look out for the drift which is happening. Okay, it can suddenly happen that while you are trained the model very well and it was working very well, but over a period of time the drift has happened, and then now it becomes a issue. Okay, so then you will have to monitor it, you will have to audit it, so that it is in line. It is not going away from the reality. And these are the principles. So see, some of these principles are actually there in that the law which is getting done in European Union, Artificial Intelligence Act. So it has 3 or 4 cornerstones. One is that it should not be discriminatory, it should be transparent, it has to be for a overall well-being of a person, should not get affected because of this. So these are some of the principles, and human oversight need to be there. So these are the 4 principles, and you have to establish all these 4 principles in your model building activity for us to get it done. And they are planning some penalties if something kind of this thing fails and all that stuff. So this is exactly more or less that is the principles what we do it. Other than that, also from a data perspective, if the data is unbalanced, if some group is underrepresented, then you kind of oversample it and then ensure that it is there. The other issue is that if there is gaps in data, for instance, if a customer is not exactly declaring the proper information, maybe it is erroneously, he is not understanding the implication, but if you are able to triangulate that information through some other means, okay, if you are able to go back and verify it with the ecosystem data, and you are able to get that information, then you kind of pass that on. And you can also depend on the regulator in IRDA. DI has an IAB Insurance Information Bureau is there, where the customer insurance details are available. So the regulator is actually enabling the industry to function in an orderly manner by providing the information, which can again be triangulated. Distributors can play a role because they are the people who are actually seeing the customer. So some of the online distributors, they can provide the customer behavior on the website, the clickstream data, which can provide you some good amount of detail about the customer behavior. So when you have these different players there and people have different information. So customer has certain information, the distributor has certain information, the regulator has a 360-degree view of the information. So all this put together, then you kind of develop the any model which actually addresses any bias in that,
So
and go
these are
through
the
that
multiple parties, each one.
Yeah, multiple party. Yeah.
Got it. Got it. Chandan, related note, as you talk to customers and they are in a wide variety of different domains, any rules of thumb, frameworks, constructs that you have in handy, which can talk a little bit about, what should customers look out for, or whoever is building models should look out for, to separate from what's working well and not working well.
See, probably that part is now slightly getting sorted. Now, a lot of commercial models are coming into play. So with commercial models coming into play, we are kind of little relaxed that we can actually consume them and do a faster development for customers. But that's something which is there on the commercial side. But there are customers, they still have their old data with them. And when we work with this kind of customers, we always focus on the accuracy of the data, the context on which they would like to build the model. Now that is absolutely necessary for my data science team to understand what are the 1, 2, 3 things customer wants us to deliver. Now whether with that data we can achieve that result or not. The modeling, before doing the actual modeling, is something that our data science team, they help with the customer. Now if you feel during the process that we are missing something, we go back and tell the customer that, you know what, probably 1, 2, 3 things are missing from your data sets. If you can give us some kind of supplementary data, that is going to help us, or else we'll figure out what else needs to be done. But with, as I said earlier, with commercial models coming into picture, this part is going to be slightly simpler for us because we are only talking about a delta learning model which customer can actually consume. Yes.
No, thank you. That's a good segue into what I was going to come to next, which is forward-looking. Generative AI, everyone talks about it. Well, first of all, question for you, Arul. Hype versus reality for Gen AI. And based on what Chandan is saying, do you think the model for innovation, especially using newer forms of, not just generative AI, but newer forms of AI, where it's low code, no code, commercial models, etc., do you think the model of innovation needs to change to address bias?
In terms of technology related stuff, for example, we are trying for 3 models specifically on code. One we were trying for code generation, another one we were trying for code refactoring, and the other one we were trying to see how we can identify these vulnerabilities and other things in the code. So if you look at today's world, I think the models which we have today uses a lot of open source data, and the obligation is to place it in Hugging Face. Because this data is all from us. It took from GitHub, it took from some of the Apache projects, and it took from a lot of the books which are available in the internet. So you're obligated to place, and I think in that model, pretty good. I think some of us are surprised to see that gives us a better logical portion of it, logical good code that we have. We continue to drive that because it's an assisted model, right? So you take the code and you assemble it and then you push back. So, and I think a lot of productivity, and what we were seeing, and I think in the industry statistical, like right now you require 2, 10, 2 will be enough to do the work. So that model for assisted is really good. And when you look at the models which are available for medical, there where the problem starts, right? So you cannot 100% rely on those models You take the model and you try to directly put to the doctor, and doctor uses it, most probably, most probable, it's a probability theory. It may or may not work for you. So, and I think one aspect that I want to tell is there is right at this moment of time, a model is learned, right? And I think you know models are very big, 1 terabyte size. It's a binary file. It consists of a lot of logical conditions. Imagine that one of the small parameters is wrong, and really it's very practical to go and remove that particular aspect of it out of that. I don't know that. So how do you have an algorithm which actually can take those small portion of logical conclusion and take it out and make the model as unbiased? It's been worked out, and I'm not sure that there is a pretty good way, but there are open source tools are in the market which actually can help you to make an unbiased model. And in the field of standardization is getting up, and Google also announced Fairness AI Challenge, and I think there are a lot of people trying to get that back. Unlearning, forgetting something what model been learned is a topic is right now is very hard, and I think a lot of people are interested too.
Thank you. Karthik, you want to add to that?
So, the way generative AI is there in the public domain is there, but it is also has a lot of scope to change the way some of the corporates work. Okay, let me take an example, your own consulting example. So, when you actually engage for a project with, let's say PwC for a consulting project, so one of the things they bring in is a worldwide expertise in terms of there could have been a similar project which has happened in Europe or North America, Japan, maybe Korea. So you get to know that, okay, this is what that happened. Now this knowledge is resting in different, different domain. Now imagine if that can be put into a, generative AI kind of a thing where somebody sitting in India can actually generate those insights from various projects which is happening, 360-degree across the world. Same even for a insurance industry, for instance. There are a lot of products which are very complicated. One of the problems with insurance industry is the products are complex to understand. It's a perception, which is not the truth, but it's a perception. Now, if somebody can build that into the website, for instance, a customer can come and actually post queries and understand, okay, I am this age, I'm this is the thing, what is the sum assured I should be taking, what is that I should be looking at. So that kind of a knowledge push can come in. And within an organization also, if there are knowledge which is there in different pockets, which can be, kind of democratized. Everybody can access it by through a simple, generative tool. So it will, I think, slowly but steadily, a lot of corporates are looking into it, this particular thing, either to modify it and kind of use it, or to develop their own thing within their own environment, kind of train it and then kind of do it. So it is going to change the way people, particularly people who are working with a little bit of which requires a little bit of a knowledge and know-how. So that area, it is going to kind of definitely have a different kind of an impact which is going to happen.
Thank you. Chandan, your comments on generative AI and bias exploding and so on?
Well, I see the world in a different way. 20 years ago, nobody believed that cloud is going to be there everywhere. So today we don't talk anything else other than cloud. Today, generative AI is almost there everywhere. Now, I'm not sure if you take some of the names like your Stable Diffusion or DALE. So they are there in their space doing a lot of work on the media side, picture side, image side. Now you can generate any kind of image. The ability of the solutions are somewhere else. Look at Codex, Duet kind of solutions. You can generate actually codes without knowing programming language. And these are 60 to 70% correct with accuracy of that level. Now you look at some of this modeled generative AI solutions. They can do a lot of stuff that we are doing on a day-to-day basis today. Right from your drafting email to correct your email to give you something on a specific note. As a researcher, as a student, as something else, you can do a lot of stuff using generative AI. Now, it is a matter of time that people are going to consume more and more response engine than search engine. So today you go to search engine to search something. Now, after searching something, probably you're going to do something else. Now, with response engine, you can just paste the question and you can get the answer. I don't have time to search. right? So that's the way forward that we are looking at. Now coming back to the question of bias, now this is one bit, if your models are biased, then essentially you will get the results which are also biased. It's a couple of examples what we have seen in the past. Now, I don't remember the bank's name, but while applying for a credit line, male versus female, female used to get lesser than male. So obviously the data which was used had some amount of bias. Similarly, the criminal justice system. So US already they have seen it is unfair towards certain race and color. Now, COVID was a classic case where actually AI failed to help us to do some kind of automation which we could have done much better for healthcare industry. Now, while Gen AI is going to be there everywhere, but is it going to change the world? I don't think so. It is only going to assist, it is going to improve your productivity. That's my call.
Thank you. That was perfect. I know we're out of time. Any time for questions? Okay. A couple of questions. Yes, please.
Check. Hi, my name is Preeti. I wanted to ask a question on the predictive models that you were talking about. Now, what happens is a lot of talk is on that as now the first set, when the AI has started and the whole prediction exercise is going on, you have a lot of genuine human responses from which the model has been generated. But as it starts predicting, the machine part becomes higher, right, as you go ahead, because then it is self-learning and self-predicting. So ethically, at what point of time the responses actually become more machine prediction than actually human? Because human beings are notoriously fickle, right? Their responses keep changing. And if the model is only going to do self-learning and doing the machine-generated answers, and if that becomes the majority of your responses, then how does even the whole question of, personalization, does it even hold true then, after a point of time?
I think there's no kind of real-time learning. Very rarely models. I'm pretty enough. But what normally happens is you take the data, you train them. If you look at GPT, it took to train $10 million to train them, get the model back. So it is 1 terabyte of data. So it's not very easy to that they constantly learn. If you look at the GPT also, they continuously change the model as and when they gather more data. So any model that you have, you have to constantly take the data and learn them. We have a fraud detection model. We normally take every 3 months a new set of. We have a profiles for customers, but we learn them, right? So as your point is right, we cannot have that the same set of behaviors from the data, because obviously customer will change time to time, and we also change. So that always addressed in most of the time.
Thank you.
Any other?
Good evening, sir. My name is Ashish. I am pursuing my master's in cyber physical systems at IIT Madras. Sir mentioned about biases arising at various stages of the model. One is the data itself, the input, the pre-processing, and the output stage you mentioned. What kind of problems arise at that level? Let's say if the data bias is kind of resolved, still there is some bias remaining. So what exactly is that?
See, essentially the inference from the data is not same for everybody. Now, there is a famous use case where I think some company, I don't remember the name of the company, and good for me. So they were trying to figure out the difference between husky and dog, and it's a very popular example. They ended up creating a model which can only identify snow. So wherever snow is there, husky is there, right? So the model actually missed the entire line of dog versus husky. Something similar happened somewhere else. They were trying to figure out how many people are there in a subway platform. Now in every platform there was a clock. So they essentially ended up training the model to learn how clock works. So the model, actually you can feed the data the way you want, but sometimes the inference goes in a different way. Now that is not something controlled by us, right? Now, these models are quite fickle also. They introduce bias by themselves. Because of certain reasons, because of certain unknown data models which is not known to us. So it is quite possible that inference what you are drawing out of that data is different for you and different for the model. So that is the risk that we always carry.
Maybe one last question.
Sorry if I can. On generative AI, yes, I was just curious. It is said that in the future, we might be able to do with much smaller teams, especially for programming, and English will be the most important coding language that you'll ever need to know. How near are we to that, and do you think this effect will also be rippled out to other departments like maybe healthcare and etc.? If you can help me there.
English anyway is the language, okay, so that's not the point. The point is how conceptually you're good are. So the logical skills holds good. Without logical skills, you will not be able to even model. The instructions, what is important for us to, how do you use the models more effectively is the instruction. So for example, can I give an instruction to the model more closely? It's not English actually, it's your logical skills and your analytical skills comes in place. So if you are really good, then that point of time also, your max skills still works, right? So if your instruction is not good, even your English is great, still it does not work good for you. So continue, the skills remain same, but the only thing is where do you apply, how do you apply is going different. That language of instruction set is super needed for the hour, when you start interacting with these models.
Perfect. Chandan, you had a point?
I think whatever Arul mentioned, I just want to add something there. See, it is very important to understand what is prompt engineering. Now, essentially, prompt engineering is something which we have to learn a lot. Now, let's say same question. Now, I want to know about world history. I asked the generative AI model, I'm a student of class 8, can you tell me something about world history? And I change the question and say, I'm a PhD scholar, I want to know about world history. These two questions are different completely for the generative AI model. So it is based on your persona you are creating, it is based on your interaction that you are creating, it is based on the prompt that you are creating. So English is going to be there because you have to prompt it using English. So NLP is not going to go away. So that is the most important aspect when you are using some of these models or generative AI. Be very particular about the prompting part because all of us can prompt the same model in different way and can get different answers. It is not that the model is actually hallucinating, it is the prompt which we are asking.
Perfect. Thank you. As we conclude this panel discussion, I'd like to express my gratitude to all of you for joining us for this fascinating conversation. You see, the insights shared today, and I was looking at my notes, are valuable not just for an organization, but I feel it's a step forward in ensuring ethical and equitable AI practices for everybody. So as we leave, let us take this commitment forward to working towards paving the way for transparent, ethical and trustworthy and less biased AI models for everyone concerned. And thank you. Let's continue our progress on making AI really what it can achieve. And till then, safe travels and see you again. Thank you.
Thank you.
Thank you.
Thank you.